Miss Collier explains!
Area of a triangle.
Today, our learning intention is to understand that a triangle can be considered as half of a parallelogram, to be able to identify the base and perpendicular height of a triangle, and to calculate the area of triangles. We will know we are successful when we can find the area of triangles. Today we're going to look at how to find the area of a triangle. Triangles in everyday life. I'm sure you can think of many examples of triangles in everyday life, right down to like Doritos. But here's a really cool example in buildings. The Flatiron building in New York City was built in 1902 on a triangular block of land. Each of its 22 floors is an isosceles triangle that kind of looks like an iron. So now we're going to explore how to find the area of a triangle. When we were trying to figure out the area of a parallelogram, we used our knowledge of the area of a rectangle. We're going to try to do that again. So we used our rectangle to figure out our parallelogram. Now we're going to use our parallelogram to figure out our triangle. Here is an image of a triangle. We can see that it's a right-angled triangle, and I can also see that I've added some lines to signify the same triangle repeated again upside down. We can see then that those two triangles form a rectangle. So it's pretty easy to see that a right-angled triangle is half of a rectangle, or could be half of a square. However, not all triangles are nice, pretty right-angled triangles that can just be repeated on top of each other to make a rectangle. Some of them are all fancy, like something that would look like this. Obviously mine's not straight or with great angles, but if I was to put that on top of each other, it wouldn't really create a rectangle. So what shape do you think it might create? If you guessed parallelogram, you are correct. Look at this example here. I've duplicated the triangle and turned it upside down and put it next to each other, and it's created a parallelogram. Let's have a look at that digitally happening again. We can see we're duplicating the triangle. They're exactly the same triangle, turning the one upside down and then putting it back together so that they're touching each other. Once we've done that, we can see that it's creating a parallelogram. Because we duplicated the exact same size triangle, we can see that that triangle is actually half of the parallelogram. This piece of information is going to be very useful to us. This last example is just to prove to you that we could turn any triangle into a rectangle by chopping it in half and then duplicating it, but it might actually be more useful for us to think of a triangle as half of a parallelogram. So then let's think about what our formula for the area of a triangle would be. Our formula for a parallelogram was area equals base times height. We can see that two triangles make a parallelogram. So two triangles put together would have the formula area equals base times height. But we only want to know the formula for one triangle. So if I've got two of something and I need to split it into groups of one, what would I do? If you said divide by 2 or times by a half, you're exactly correct. So the formula for our triangle is going to be area equals base times height divided by 2. Firstly, we're finding that base and the height, which will make a parallelogram, and then cutting it in two to form only our triangle. All the same rules apply as finding the base and the perpendicular height as they did when we were looking at our parallelograms. So here's our formula. The area of a triangle is the base times height divided by 2, remembering that the height is perpendicular height. Let's have a go at finding the area of a triangle. Find the area of each given triangle. A. First thing, write the formula. Area equals base times height divided by 2. Now we're going to replace it with the values that we know. So the base of this triangle is 10. The height is the perpendicular height, which is 9 centimeters, divided by 2. 10 times 9 is 90. 90 divided by 2 is 45. And of course, we're putting our units, which is square centimeters. 45 square centimeters. B. First we write our formula. Area equals base times height divided by 2. Now we replace our values. The base of this triangle is 6. Now, remembering that the base must be on the flat edge, and here's our flat edge, all right? Base doesn't mean it's at the bottom, remember that. And then our height means the thing that is perpendicular, it's sitting at right angles. And we can see that they've drawn their perpendicular height outside of the shape here, and it is 9 meters. We know it's the perpendicular height because it's sitting on that right angle to the base. And divided by 2. 6 times 9 is 54, and 54 divided by 2, well, 50 divided by 2 is 25, 4 divided by 2 is 2, so I'm going to say 27. And the units is square meters. So, 27 square meters. You have a go at finding the area of these triangles. Let's check your answers. First of all, let's write out our formula. Area equals base times height divided by 2. The base of this triangle is 12 and the height is 7 divided by 2. 12 times 7 is 84 divided by 2. 84 divided by 2. 80 divided by 2 is 40. 4 divided by 2 is 2, so it's going to be 42. And it's square centimeters. B. Formula first. Area equals base times height divided by 2. The base here on the flat edge is 8 meters. And the height on the right angle is 6 divided by 2. 8 times 6 is 48 divided by 2. 48. 40 divided by 2 is 20. 8 divided by 2 is 4. 24. And the unit is square meters. How did you go? I hope now you can use the formula area equals base times height divided by 2 to calculate the area of a triangle.